Today myself Radhika Moral is here to demonstrate the lecture on the topic carbon and its compounds. So the first question which might be coming to your mind is why we are studying about carbon and its compound? Why not about nitrogen and its compound or oxygen and its compound? So to answer this question, first of all, look at the carbon element. So you all know that the element carbon has the symbol C and it has the atomic number 6 and mass number 2. Isn't it? Now, we have studied it in the 9th standard that the number of the atomic number is equal to the number of electrons and number of protons. So from here we can say that number of electrons in carbon is 6, C, proton is 6, and as we know that mass number is equals to number of protons plus number of neutrons. That means as the number of mass number is 12, so here from here we can say that number of neutrons is also 6. So the carbon is the element which carries 6 electrons, 6 protons and 6 neutrons. Isn't it strange? Isn't it unique? So whether it is a unique element or not, we'll answer. We have to find out the answer of this question only. So now first we will go to the electronic configuration of carbon. So we know that according to the Bohr's model, the electrons are distributed among the shells and this is known as electronic configuration. Now let's write the electronic configuration of carbon as an element. So the electronic configuration will be 2, 4. Why 2, 4? We know that the first shell has the capacity to carry 2 electrons and the second shell has the capacity to carry 8 electrons. How we have come to know? We have come to know by the rule 2n square, where n stands for the number of shell. Okay, so 2, 4, as there are only 6 electrons in the carbon, so the electronic configuration becomes 2, 4. Now the question which arises over here is that how the carbon will form the bond? Because carbon has the 4 electrons in its outermost shell, hence it is tetravalent. So you all have, first of all, why do the carbon will do the bonding? Because carbon has the incomplete octet and we know that every element tries to become like a noble gas element, tries to acquire a electronic configuration of noble gas elements. So now how the carbon will form a bonding here? Just think for a while. So the answer is pretty simple for you all. You will think that, okay, carbon will do one thing, or I should say from the point of view of carbon, carbon will do one thing, carbon will gain the 4 electrons, or is it possible? Okay, let's say carbon gains 4 electrons and carbon becomes P4 minus. Is that possible? Think for a while and then we will answer. Or what else carbon can do? As there are 4 electrons, so carbon has both the option. It can either donate the 4 electrons. So it can do one more thing, that it can donate the 4 electron and become C4 plus ion. Sure. Now let's think from the point of view of carbon. Now what does the carbon say on this? That okay, I am ready to give the 4 electron. Carbon says, I am ready to give the 4 electron, but the energy is not available to me for ejecting out the 4 electrons, because we know that there is an ionization energy required for any element to become an ion. Okay, so eject out its ion. That much energy is not available in the environment so that it can donate 4 electrons. It's not possible because of the energy barrier. So this option is not possible with carbon. Now what the carbon? Now the carbon will say that, okay, don't test. I can do this. But the here problem arises that we all know the Bohr's atomic model of a carbon. So let's draw the Bohr's atomic model. And according to the Bohr's atomic model, there are the protons and neutrons present in the nucleus and the electrons revolve around the nucleus. So this one is nucleus and this are the shell of the electron. Here there will be a 2 electron in first shell and 4 electrons in outermost shell. Now how we came to know that it is tetravalent? We have calculated the number of electrons at its outermost shell, and till the 1 to 4, if the outermost shell carries 1, 2, 3 or 4 electrons, that means it has the valency also equal to that. If it carries more than 4, then the valency becomes 8 minus the valence electron. This everyone might be knowing. Now, here there will be protons in that proportion itself: 1, 2, 3, 4, 5 and 6. Now what happens? So let's do one thing. Carbon will have gained the 4 electrons. But what happens? We all know that the electrons are holded by protons. But now what will happen? That protons are just 6 and now 4 electrons will come. So the proton will not able to hold the 10 electrons, because 6 plus 4 will become 10, and it will not be possible for the protons to hold 10 electrons, 6 protons to hold 10 electrons. So now the carbon has to cancel the bonds. Now what the carbon will do? Now carbon say one thing that okay, let's do one thing. What I will do? I'll neither lose the electron nor I'll gain the electron. I'll do one thing. I will share the electrons. What the carbon will do? Carbon will share the electron. Now, what is the meaning of sharing? It's just same like when you share your pencil or pen with your classmates or with your friends. So what does it happen? That or else your teacher gives you one chocolate and it says that share among your friends. Okay, so the chocolate doesn't belong to any one student. It belongs to all. In the similar way, carbon also tries to say that okay, I share the electron and the electron will belong to me also and to the atom with which I am sharing. So how it will form and such bonds which are formed by the sharing of electrons are known as covalent bonds, and such compounds are called covalent compounds. Now, what will happen? Now, let's take an example of hydrogen. It's not that only carbon forms covalent bond, many others are there. So, let's take an example of hydrogen. Now, we know that hydrogen just carries 1 electron in its outermost shell, isn't it? And we know that first shell requires only 2 electrons and the shell becomes complete because it can acquire only 2 electrons. So it also try to become like a duplet. So another hydrogen will come having single electron. What it will do? It will form a bonding. And this type of bonding is known as covalent bonding. Clear? Now, a covalent bonding can be also of 3 types: single bond, double bond, and triple bond. Single bond is like one electrons are shared by both the elements. When both the elements share 2 electrons, that such bonding will be called double bonding. Now let's take an example of oxygen. We know the oxygen has atomic number 8, so its electronic configuration becomes 2, 6. So it has 6 electrons in its outermost shell. So 1, 2, 3, 4, 5, 6. Now what is this which I am drawing? It is nothing but the Lewis electron dot structure. Means when we draw the symbol and around the symbol we write the valence electrons along it is known as what? Is known as Lewis electron dot structure. Now we will take another oxygen and we will also draw. Now what happens? It shares 2 electrons each. Now as you can see here, now see, so it has formed double bond. Now first oxygen, this one oxygen which I have drawn with white chalk is also carrying 1, 2, 3, 4, 5, 6, 7, 8. Now these 2 electrons also belong now. These 2 electrons will belong to the host. In the similar way, Covalent bonding can be triple bonding. So the triple bonding is seen in nitrogen N2. We know that nitrogen carries 5 electrons in its outermost shell, so we will draw. And it requires more 3 electrons to complete the top. So what it will do? It will share it with another nitrogen. So see here. Now, and this type of bond are represented by like H2 can be represented H dash H, O can be O double bond O, and 2 and triple bond. So this is all about the covalent bond. So hence we have come to know that the carbon also forms covalent bond. Now, why does so many compounds exist in carbon? Of carbon. So the reason first we have discussed is tetravalency. Hence it forms a covalent bonding. Okay, this is the first one. Now how does the carbon form? So for answering this, we'll just take a methane, which is CH4. Okay. Now how does the CH4 is formed? We know that carbon has 4 electrons in its outermost shell. Hydrogen has one electron, isn't it? So each hydrogen will share its 1 electron with carbon, and in this way 4 electrons, 4 hydrogen will share. Now both are happy, carbon is also happy and hydrogen is also happy. So it becomes CH4. This is methane. Now both are happy. Now the question which arises, why it forms so many compounds? It is due to the property of catenation. Means tendency of forming a big chain. Now why does it form big chain? Because carbon is a small element. So hence what happens? Like now if I remove hydrogen from here, I have put carbon, one carbon, and now what will happen? One carbon will have 3 hydrogen, this carbon. Now another carbon will have more its 3 hydrogen. So it will form C2H. I hope that you all are getting what I am trying to say. Like, see here. Now carbon has 4 electrons. Now what we will take another carbon. It also has 4 electrons. Now what does carbon will do? It will share one carbon with a neighboring carbon, and other will be a hydrogen atom. Now like this one. So in this way, now again we can remove this hydrogen, and in this way carbon can form a many chains. This. So the carbon has formed such a large number of compounds that now we have the different branch of chemistry for the carbon, and that is known as organic chemistry. In your higher classes, you will be studying a different subject known as organic chemistry, and you will be surprised to know that people are even doing research, and on this topic people are doing research, and there are more sub branches of organic chemistry. So you can see here that how modification the carbon has done in itself, and how the carbon has formed a different branch of chemistry known as organic chemistry. So this was all about the carbon and its compounds. I hope that you have understood. Thank you and have a nice day.